Welcome my dear student. So today I am going to discuss about the motion of a particle, charged particle under the influence of both electric and magnetic field. So this topic has already been covered. Now today we will discuss two different situations. So where the velocity vector, electric field vector and B vector are mutually perpendicular to each other. So this is the case number 4a. Okay. So if I say that velocity vector, electric field and magnetic field both are perpendicular to each other, and under that situation, I know that the total force acting on the charged particle is the Lorentz force. So this is the Lorentz force acting on the charged particle, and that force is basically the vector addition of the electric force plus the magnetic force. Okay. Now in this situation, what is happening? So since the particle is moving toward the x direction, so this is our x-axis. So along the x direction, the particle is moving. Along the y direction, the electric field is acting, and along the z direction, let us say the magnetic field is there. Okay, so because of this charged particle, it is moving on the x direction. So charged particle will feel a force in the upward direction by the electric field. So this is the direction in which the electric field will be acting, and accordingly, the force will be Q into E on the charged particle. Similarly, because of the charged particle moving under the presence of the magnetic field, so there is a downward magnetic force that is equals to our Q into V into B. So Q into V into B is the magnetic force. Now, in this situation, if this upward force and the downward force balance each other, that means the net force on the particle becomes zero. Okay. So in this situation, if the net force becomes zero, so I am getting the condition that Q into E should be equals to Q into V into B. So that gives a particular value of velocity for which this can be happen, and that velocity is equals to our E by B value. Okay. And that velocity is used in case of velocity selector. So path will be a straight line because the particle is moving under the force, combined effect of electric force as well as the magnetic force. So since these two forces are cancelling each other, so what I am saying that the particle is acted upon by no net force, zero net force. So the path will be a straight line, and that particular concept is used in case of velocity selector, where I want to get a charged particle should move in such a way so that it is moving along a straight path. Okay. So under that situation, so you have to maintain this particular velocity so that E by B should be equals to V. So that is the one situation. Now we discuss the another situation where again the velocity vector, E vector, B vector are mutually perpendicular, but now the path is not a straight line. So path is a cycloid. So that is a quite interesting path, and I want to discuss about the trajectory of this particle, how it moves, and what are the different forces acting on it. So again, let us say there is an electron which is moving under the presence of both electric field and magnetic field. So, according to the vector notation, so electric field is acting along this our negative y direction. So, can I write it is equal to minus E into J? Okay. Similarly, magnetic field B vector is acting towards the negative Z direction. So, that is equals to our minus B into K. Okay. So these are the two vectors acting on a particle. So, this electron will experience a force of QE plus Q into V plus V. So let us say at any instant the particle is moving with a velocity U vector, and that is nothing but our, let us say, Vxi plus Uyj. So these are the two velocity component of the particle at any instant of time. So because of this, net force can be calculated as a vector that can be calculated as Q into E. So Q is minus E, charge of the electron is minus E, and E is minus E into J cap. Okay. Again minus E into what is the V vector? V vector is Vxi plus Vyj cross B. B is how much? Minus Bk. Okay. So this minus and that minus become positive. So ultimately it becomes E into capital E J plus E into B. E not E into B, so E into Vxi plus Vyj cross Vk. Okay, so I cross K becomes minus J. So it gives E into minus Vx V into J, and J cross K becomes plus I. So plus Vy V into I. Okay. So that is the final force acting on the electron. So if I rearrange it, So ultimately I am getting, so taking the I part common and J part separately. So can I write that E into Vy into B is the I component of the force? Similarly, plus E into capital E minus E into Vx into B, that is the J component of the force. So the particle is acted upon by two different forces. One is along the x direction. So if I say this component of force is the Fx force, x direction force, this component of force is the Fy type of force, force acting along the y direction. So because of these two forces, the particle whose mass is, let us say, m, will experience acceleration in both x and y direction. Okay. So now moving on to the calculation of acceleration, let us say I am getting the value of Fx equals to E into Vy into B. That is the Fx part. And similarly, Fy is equals to how much? Fy equals to our E into capital E minus Vx into B. Okay, so these are the two different forces acting on the particle. Correspondingly, I can also say that the acceleration along x direction should be equal to E into Vy, B by m. Similarly, acceleration along the y direction should be equal to E into capital E minus Vx into B divided by m. So these are the two components of acceleration acting along x and y direction separately. Now this x can be written as equals to d Vx dt. Similarly, this can be written as our d Vy dt. Okay. So these are the two accelerations. So let us say this is the equation number 1 and let us say this is the equation number 2. If we further differentiate equation number 2 with respect to time, okay, that means I want to get the value of d dt of dvy dt. That means, okay, that means I am getting the d2vy dt square. That should be how much? E by m take outside and capital will give the 0 result. So minus Vx into B, not Vx, it is dVx dt minus B into dVx dt, right? So this is the value of second derivative of the Vy. So now what is dVx dt? From equation number 1, I can put the value of dVx dt over here. So if I substitute the value of dVx dt from equation number 1, it gives minus EB by m. And what is dVx dt? That is equal to EB by m into Vy. EB by m into Vy. So that means I am getting that minus EB by m whole square into Vy. Okay. That is basically the value of d2 Vy dt square. Okay. So if I look onto this equation, so this is equation representing in the form of d2 Vy dt square, that can be reduced to minus omega square into Vy. So that is a simple harmonic equation. Okay. Where omega is how much? Omega is equals to EB by m. There is omega value. So it is equation representing a SHA. The solution of this equation is a well-known solution. So solution can be written as Vy should be equals to amplitude A into sine of omega t plus theta. Okay. Now, next task is to calculate the value of A and theta. Now initially, the electron is projected. Initial means at t equals to 0. So, the particle electron is released. Okay. So, it is given that the electron is released at t equals to 0. So, that means what you can say at t equals to 0, Vy equals to 0. If I put Vy equals to 0, at t equals to 0, that means A sine of theta, that is equals to 0. So, that means theta equals to 0. Okay. So, what it gives, basically, it gives the value of Vy should be equals to A sine of omega t then. Okay. Now, next task is to calculate the value of A. What is A? A is the amplitude. Okay, A is the amplitude. Now, A can be calculated. A can be calculated from the information of the value of Vx. So, at t equals to 0, also the Vx is also 0. Why? Because the particle is released at this position. So, can I say that at t equals to 0, the Vx number is also 0. Okay, Vx number is also 0. Now, from the equation number 1, what we can say that dvx dt, that number is equal to e vy by m. E vy by m, and dy dt, that from equation number 2, that is equal to this number. So since we know that vy is this number, so I differentiate this vy. I differentiate this vy, so that means let us say equation, this is equation number 3. So if I differentiate equation number 3, so what I'm getting, that I'm getting dvy dt should be equal to how much? A omega into cos of omega t. And that should be equal to how much? dvy dt is the differentiation. So that is, if I equate with the equation number 2, that is nothing but E by M into capital E minus Vx into V. Okay. So I differentiate this dvy dt number and equate with the equation number 2. So at t equals to 0, again you put the at t equals to 0, then Vx number is equals to 0. If this Vx number is equals to 0, that means we are left with only E, capital E by M. And what is that? Cos value. So cos value becomes 1. So that means I am getting A omega equals to this number. So finally what we got, A equals to E by M into omega number. Now what is omega? Omega is given as EV by M. If I put it at EV by M, so finally I am getting A equals to how much? That is capital E by V. Okay. So this is the amplitude of the velocity. So finally what you can write, that the velocity of the particle along the y direction, that is written by E by B into sine of omega. Okay. And I also know the value of omega. So this is the variation of the velocity. Okay. Now if I go inside the calculation of the path, so can I say that if the particle is bending like this way, so there is one time at which this velocity along the y direction becomes 0, or what you can say, the velocity becomes perpendicular to the y-axis. Okay. So this is the position where I am getting that velocity vector is perpendicular to y-axis. Perpendicular to the y-axis. That means it has only Vx component. Vy becomes 0. Vy becomes 0. So Vy will be equal to 0 again. So initially at t equals to 0, it is 0. But there will be another time where the Vy becomes 0. What is that time? That time should be equal to when the omega t becomes pi. Okay. So when omega t equals to pi, then again the Vy becomes 0. That is t equals to pi by omega. After pi by omega time, the velocity along the y direction becomes 0. That means pi divided by omega. Omega means, I have already said that this equals to E capital V by M. Okay. So this is the time after which the particle becomes perpendicular to the y-axis. That means at that point, V perpendicular, that means the velocity along the x direction is always there, but Vy becomes 0. Okay. Now, so we got the expression of the t. After what time the velocity becomes perpendicular to the y-axis. Now, if I look into the Vy number, so Vy equals to how much? I am getting that E by B into sine of omega t. Now, if you integrate it, so dy means dy dt. So displacement along the y direction, that should be equal to E by B into sine of omega t. Okay. So if I differentiate, if I integrate it, so y becomes how much? E by B, so dy 0 to y, that should be E by B into sine of omega t dt. Okay. From 0 to t. So if I integrate it, so that means it becomes y should be equals to how much? E by B into 1 minus into divided by omega into 1 minus cos of omega t, if I put the limit. Okay. So that means this is the variation. This is the variation, that is E by B omega into 1 minus cos omega t. So at t equals to this much time, at t equals to that much time, so if I put that equals to, that means E by B omega into 1 minus cos of omega t. So omega into t means pi m by EB. Now what is omega? Omega is equals to again EB by m. EB by m. So EB by m cancels. So cos of pi. So cos of pi is minus 1. So minus 1 to minus 1 is plus 1. So it becomes 2. Yeah. So it gives 2 capital E by B omega. That is the y maximum. So this is the value of y at which the velocity becomes perpendicular. So that means This is the amplitude of y. So this y I am calculating. This is the y maximum. Okay, so maximum, this is the displacement of the particle, and that is equals to how much? That is equals to 2e by b omega. Okay, so 2e by b omega. So if I further simplify it, so it should be equals to y maximum should be equals to 2e by b omega b. And what is omega? Omega equals to e by m. E b by m. So ultimately, what I am getting 2em divided by E into b square. That is the y max. So this is the maximum displacement of the particle along the y direction. This is the maximum displacement of the particle along the y direction. Similarly, if I go for the calculation of the x, acceleration along the x direction. So acceleration along the x direction is nothing but our fx by m. So if I go for the acceleration along the x direction, so that is nothing but our fx by m. Fx by m. Now, what is the force along the x direction? That is equals to E into Uy into B divided by m. Okay, so that is the velocity, that is the acceleration along the x direction. So it is a function of Uy. So I have already calculated the Uy number. So what is the Uy number that I have got? That is the value of Uy should be equals to E by B into sine of omega t. So this is the variation of the velocity along the y direction. So if I put it over there, so that means I am getting the acceleration in the x direction, that is equal to Eb by m into E by m, E by b multiplied by sine of omega t. Okay, so b cancels out. So ultimately I am left with E capital E by m into sine of omega. That is the acceleration on the x direction. So once I got this acceleration on the x direction, so now that is nothing but dvx dt. That is nothing but dvx dt. That is equals to E capital E by m into sine of omega t. So if I integrate once, so I am getting the value of Vx. So correspondingly on integration, Vx should be how much? E by m omega. E by m omega into 1 minus cos of omega t then. Now, so I am skipping one particular step. So from this point to that point, that means I am integrating it and putting the limit. I have already put in the limit, so I am getting the value of Vx. Similarly, if I differentiate it further, so Vx is how much? Vx is equals to dx dt number. Okay, dx dt number. So that gives E capital E divided by m omega into 1 minus cos of omega. This number. Okay. So if I differentiate, integrate it once, so ultimately I am getting x equals to how much? X equals to E by m omega. E by m omega multiplied by integration of t. So with respect to t means t minus sine of omega t by omega. So that will give the value of x. Okay. So this is the x variation, and earlier I got the y variation. So y variation is basically our y is equals to E by b omega into sine of 1 minus cos omega t. 1 minus cos omega t. So this is the variation of y. This is the variation of y. Okay, and that is the variation. So this will give the value of displacement of the particle at any time t. So this is a cycloid function. So particle will follow this particular path, which is known to be a cycloid path. What is this point? This is the amplitude. Amplitude part along the x direction. So there is another amplitude along the y direction. So this kind of variation will be observed whenever the particle is projected in a medium where both electric field and magnetic fields are there and which are perpendicular, mutually perpendicular. Okay. So the path of the particle will be cycloid. So this is the most interesting part of the case where we discuss about the existence of the cycloid path. Okay. Hope you understand this. Thanks for watching the video. If you like it, please subscribe my YouTube. Thanks and bye.